I welcome you all to this lecture. I am myself Madhumita, Assistant Professor ECE from Rathanam Technical Campus. Today in this lecture we are going to see what is a feedback amplifier is under an analog IC design. Before getting into the topic directly, I just ask you a question from you all guys. Why do we need to study analog IC design? So nowadays all of us are using mobile phones, smartwatches, even our Bluetooth Wi-Fi, earbuds. Have you ever wondered how those tiny gadgets are capable of processing that huge signal? And another question is smartphone capable of understanding a human voice? The answer is absolutely yes. In order to smartphone to understand a human voice, we need a microphone to record the voice, and we need a amplifier to amplify the signal, filter to reduce the noise signal, and finally analog to digital converter to convert the digital data. All these components are designed based on the concept of analog IC design. That's why analog is the bridging gap between the real world data and the digital data. So at the end of this session, student can able to understand what a feedback is and define what a feedback amplifier is, and can able to distinguish between the positive and the negative feedback. Finally, can able to classify the different types of feedbacks. Before getting into the topic directly, I must ask you a question. One, does a system can able to rectify its mistake by its own? The answer is absolutely yes. By continuously monitoring the output and changing the input accordingly will make the system to rectify the mistake by its own. The second question is, everyone has been experienced this situation at least once in a lifetime. When you place your microphone under a speaker, it started screeching sound. So do you know why? The reason behind it is, let me explain this reason in the middle of the lecture. And getting into the topic, what is feedback is? Not a technically, normally what is a feedback? A vocabulary that means we are feeding back something to the system. Technically that is also a thing. Feedback is nothing but a small amount of an output has been fed back to the system. So that is what a feedback. So by feeding back the output to the input, what happens in the sense is, the system becomes a closed loop system. So in this case we can able to predict the output and the output is accurate. So we have seen what is a feedback is. Why do we need a feedback? So we are operating our electronic gadgets under different circumstances, like at extreme cold, extreme hot, and at different power supplies. At all the circumstances, a gadget cannot work similarly. So all the external factors will affect the behavior of the system. So in that case, if a feedback is absent, what happens? We cannot able to predict the output, and the output may become inaccurate. For that condition, we are introducing a feedback here. What happens here? Feedback continuously monitors the system performance, and based on that, it will improve the input to make the output more accurate. So we have seen what is a feedback is. The next topic comes, what is an amplifier is. So we all know that amplifier is an electronic circuit that is used to amplify the signal. So this is what the block diagram of an amplifier. Amplifier operates at the DC power supply. We are giving a weak input signal to the amplifier. At the end, what happens in the sense, we will get an amplified output signal. So amplifiers are used to amplify the weak signals. So we have seen what is a feedback and what is an amplifier. Now as a whole, what is a feedback? So we have an input signal, we have an output signal, and a feedback network. So the output of the amplifier is fed back to the amplifier through the input. So this forms a closed loop system, and based on the feedback provided to the amplifier, that feedback can be classified into two types. Let me discuss it later, and it can be used. So the types of feedbacks are positive and the negative feedback. Positive feedback is nothing but the output of the amplifier is added to the input. That is what the positive feedback. In this case, what happens in the sense, we will get a high gain, whereas it produces oscillations. So it cannot be preferred for the amplifier circuit. So positive feedback is widely used in multivibrators and oscillators. Negative feedback is nothing but the output of the signal is added with the feedback signal and fed back to the amplifier. What happens here is the overall gain is slightly decreased, whereas the topic of stability and accuracy increases. So that's the reason negative feedback is more often used in the amplifier. As I discussed earlier, why positive feedback cannot be used is, I will explain with this two examples. So as the question I raised in the beginning of the session, what happens when you keep a microphone near a speaker? What happens in the sense is, the output from the speaker is fed back to the input of the microphone, and the microphone amplifies the signal and fed the output to the speaker again. So this happens, this screeching sound. And finally, high sensitivity. Think that you are on a call, you are talking to your friend, a continuously echo sound is disturbing you. Will you continue the call? So these are all the reasons positive feedbacks cannot be used in the amplifiers. So why negative feedback is used? So think a scenario. You are making your car cruise for 80 km/h. So you are traveling in a mountain. When you are sliding down the mountain, what happens in the sense is, the speed automatically increases and the engine power, what happens? The engine power is reduces. When you are uphilling, what happens? The speed increases and the engine power decreases, right? So in this scenario, the negative feedback continuously monitors the scenario, and based on that, the input will also be changed. That is why negative feedback is used to the amplifier. And this negative feedback is classified into four different categories, that is voltage shunt, voltage series, current shunt and current series. So the classification is based on the output sampling and the input mixing. Here the output is sampled and the input is mixed. So what are it can be of two types, either voltage or current, and mixing can be in two different categories, either in series or in shunt. Shunt is nothing but a parallel mixing. So by using this four different classification, it has been classified into voltage shunt, voltage series, current series and current shunt. So voltage series feedback, in the sense, what happens in the sense, the output is fed back. Here the voltage is sampled and the output is been given to the input in the series manner. This is what the block diagram. Here the output voltage is sampled and given back in the series connection. And whereas in voltage shunt, here the sampled thing is also voltage, and what the difference between the series is, we are applying the feedback parallel to the input. So here the output is sampled, voltage is sampled and applied input in the parallel manner. The same follows for the current series and current shunt. For current series, the output sampled is current and the input given is in the series format. Whereas in the current shunt, the output current is sampled and the mixing is been done by using the parallel manner. So these are all the four different types of feedback topologies. So the usage of voltage series is audio amplifiers, and voltage shunt feedback is trans impedance. It can be used in your automobile headlights, and current series can be used in LED drivers, whereas for street lamp, and current shunt is used for battery management. So that's all about today's lecture. We'll meet you on the next lecture. Thank you.